As I mentioned at the start of class, today is a big day for us when it comes to the math that we do. We introduce what is called a mole. Atoms are super duper tiny. Again, in your reading guide, it addressed how tiny they are. Chemistry occurs at the atomic level. And starting in this unit, you're going to have to explain chemical phenomenon at the atomic level. Now, you talk about particles a little bit when you talk about mass and pressure in the last unit. We have a lot more in depth to go into this year. Because atoms are so tiny, however, it's hard for us to visualize that. And that's one of the tricky parts about chemistry is you have to be able to visualize what's going on. There's a lot of mathematics within chemistry that we now have to start introducing you to. And that mole idea allows us to do that. There's a scientist named Avogadro who came up with enough atoms that it's a handful, a heap, or a pile. So for example, in front of the room, I have a mole of carbon right here. Aluminum beads we did density with last unit. Here is a mole of aluminum beads. It doesn't have to be for individual atoms. It could be for compounds as well, which we will get into later this unit. So for example, here's a mole of table sugar. Since an atom is so tiny, it takes a ridiculous number of atoms to be a handful. Although some atoms are bigger than others, some molecules are bigger than others, so that handful can vary. On the top paragraph of this sheet that you picked up on the way in, the very last thing gives you Avogadro's number, 6.02 times 10 to the 23rd. That means 602 with 21 zeros after it. That's how many atoms are in this flask right now of 1 mole of carbon. Since an atom is so ridiculously tiny, it takes a huge number of them to be enough that we can visualize. Over the next 2 class periods, we're introducing you to mole conversions, and then every 2 weeks or so, we have to come back because we have to add on to that knowledge. So today is the first day, and really our main goal is to get comfortable with this number, 6.02 times 10 to the 23rd. How to use that in calculations. Recognizing that a mole, as the second paragraph is talking about, is a chemist's dozen. When someone says there's a dozen of something, well, that's 12 of something. Well, a mole is 6.02 times 10 to the 23rd of something. So that's what the second paragraph is addressing. Finally, the third paragraph on here is mentioning that this is a measurement. This is a quantity for chemicals. By the way, mole is abbreviated MOL. Might be silly to abbreviate a 4-letter word. However, we can't abbreviate it M. Meter was already taken. We can't abbreviate it ML. That's milliliter. MO is an element on the periodic table. That's number 42. So we still abbreviate it because it is going to be used so often for the rest of the year. I like to joke with students that by dropping that E in the word mole, over the course of this entire school year, you're going to save yourself about 5 or 10 minutes. Just because we're going to be writing that so often. So every time we go through this, you gain a second or 2. Now on this practice sheet, it shows you the 2 conversions that we're going over today. And this is day 1, trying to take it easy with you, where we're just going to do how to use Avogadro's number. So we can have it starting with the number of moles, which remember a mole is kind of like a handful, a heap, or a pile. And we can convert to atoms because we want to know how many at the atomic level things are there. The second example on this worksheet starts with atoms, but it's hard to visualize that big of a number of anything. So instead, we can convert it to moles. In particular, this second conversion is the one that you have to be careful when you use your calculator. So really, I have a few goals here today when it comes to mole conversions. First off, introducing to you this new conversion that you have to do. No longer metric that you can do in your head by any stretch of the imagination. Secondly, we got to know how to type this in correctly. We got to get comfortable with our calculators with really huge numbers. That's why last unit we went over conversions. We went over scientific notation to get you ready for when we need to really use it. So if I look at the first example problem, I'd like to do that with you right now. It says, how many atoms would 0.612 moles of copper be? What you should always start off with is write down the number that's given to you within the problem. Just like you would in a metric conversion. So 0.612 moles. Now I typically like to write down the element as well. I understand, however, that you guys early in the process might not know that copper's symbol is Cu on the periodic table. Starting next class, however, we are going to see that we need our periodic table in order to do some of the conversions that we're about to do. So you want to get used to using symbols as well. We will be very familiar with symbols throughout the course of the year. You never have to memorize them because you're given a periodic table. However, the more comfortable you are with it, it will save you time. No longer do you have to write out the word copper. No longer do you have to look at the periodic table to find what is its symbol. So get used to it now. Put in the time now of looking at your periodic table to find the symbols so that later things will go quicker for you. Just like in metric conversions, look at the question, identify what you're trying to solve for. Atoms. That is going to go on the top of the conversion. The bottom of the conversion is what you already have for a unit, which is moles. Just like with metric conversions now, figure out what numbers would fit in here to make that an equality. Because conversions don't change the amount of something, they just put it in a different unit. And our conversion, atoms are super duper tiny. So we need 6.02 times 10 to the 23rd of them to equal 1 mole. Remember when we did a lot of metric conversions, the base unit had the number 1 in front of it? Mole was kind of like our base unit here. So what you would do is you would multiply because the number's on the top of the conversion. And this is where we need to be comfortable with our calculator. Your options are doing times 10, then the caret and 23, or one of the things that I showed you a few weeks ago with scientific notation is directly above the number 7 on your calculator, there's a little comma, but the second function is the EE button. That EE button means times 10 to them. So you can actually type in 6.02 EE23, and that would mean that exact same thing. When you get a final answer, odds are there's going to be a whole bunch of numbers written on there. 2 things to be aware of. First off, if our final answer is in atoms, we need to look at the far right-hand side of our calculator where it says, for this problem, E23. In other words, we have to know our power of 10. Secondly, we abide by the rules of significant digits. 0.612 has 3 significant digits. Our final answer should have 3 significant digits. So this one, I get 3.68 times 10 to the 23rd. Again, some students just write down 3.68. But remember, John Dalton said in his atomic theory, we can't split atoms. We're never going to be working with 0.68 atoms ever. Atoms are so tiny, you need a ridiculously big number of them to amount to anything, really. That's where that 10 to the 23rd comes into play. Our unit should be atoms. Just like on your test when we go over that at the end of the hour. 1/4 of a point is for sig digs, 1/4 of a point is for unit. If people forget the 10 to the 23rd, I take off 1/2 a point because their number is wrong. Now, if you were to look at my answer key, I also label of what element. That is not a requirement yet. And what I mean by that is second semester, when we introduce mole conversions with something called stoichiometry, then we do need you to, we require you to label of what. Again, I think it's good practice to get used to. Some people, however, just call it atoms, and I will accept that. Now, I didn't actually count out 6.02 times 10 to the 23rd to get this amount of carbon. That actually would be impossible. That amount of time, it would never happen. Same with the aluminum and the sugar. Instead, the second conversion that at first we weren't going to get to today, but I think we have time, and considering that we don't have a lot of time on Thursday, I want to get to, is introducing how our periodic table helps out with that as well. So the sheet that you just now have in front of you is titled molar mass. Molar mass refers to how many grams is 1 mole of something. And after all, grams measures mass, molar, mole, the term kind of makes sense what it's referring to. So on this sheet that you picked up on the way in, there's a couple of paragraphs talking about it. The important part is look at this periodic table entry for iron. The number 26 is what's called its atomic number. That's the number of protons it has. The 55.845 is the atomic mass. And that atomic mass is an average, something that the reading guide actually addressed a little bit, and we'll talk more about that in the coming class periods. Typically, what we do with this number, this average atomic mass in the periodic table, is we can use that number of grams to convert back and forth between moles. So not only today are you introduced to how we can convert from atoms to moles, because after all, chemistry occurs at the atomic level, but now we are going to do a little practice of going back and forth between grams and moles. Grams is what we can measure on a scale. Moles is that unique unit to chemistry that helps explain a lot of things, and we're going to do a lot more mole work throughout the year still. One last thing I want to mention about this number is that usually on the periodic table, some of the numbers go on and on for a while, others go a little bit shorter. We round off to the hundredths place for that number here. So we usually don't report it as 55.845 grams per mole. We call it 55.85. A couple reasons why we do it. It's very common to be rounding off to the hundredths place. I know, for example, AP Chemistry, the periodic table that they're given by the College Board rounds off to the hundredths place. But secondly, you guys have scales that go to the hundredths place. So I could ask you to measure out a mole of something, and you could go to that place. On the middle of this sheet, it gives you a couple of practice problems. For example, the first one, if we give you the amount of gold, and we ask for how many moles, notice what they did to solve. They wrote down what was given. They set up a conversion, but now that conversion is using the periodic table, which is why if you have a periodic table handy, why don't you get it out right now? I mean, if your vision is good enough, you can see that one over there, but the numbers are kind of small. Example problem number 2, if you're given moles, you could solve for grams. So here's what we're going to do, ladies and gentlemen. I want to go over with you the 2 problems on the bottom of this sheet. So that's going to be try it questions 1 and 2. We're going to stop at that point. We're going to save the back side of this as kind of our warm-up to start next class period. Because next class period, I want to take this a step further beyond this. But that way, we're already catching up and making up for lost time because of homecoming on Thursday. So, if I look at question number 1, it says, how many moles would 8.02 grams of carbon be? Again, I'm given 8.02 grams of carbon. Rewrite that number right away. And again, I like to write down the symbol because if you're going from grams to moles on the periodic table, you need your periodic table. You need the molar mass of carbon. In this particular question, it wants me to solve for moles. So moles is on the top of my conversion. I have grams given to me, so I'm going to put grams on the bottom. I am showing you a second conversion today besides the Avogadro's number, 6.02 times 10 to the 23rd. However, the nice thing, and this actually continues for all of this unit at least, there's only one number you will ever put in front of the number mole in this entire unit in a conversion. What is that one number, Eric? 1. Every element, however, is unique in their size. Different numbers of protons and neutrons. After all, different amount of space for a mole of carbon versus a mole of aluminum. That's where we look on the periodic table. And if you look on the periodic table, above the C, it gives you the number of grams per mole, the molar mass of 12.01. That's right, Allie. I didn't have to look at the periodic table because I have it memorized. You will too. Not because I'm asking you to. We are going to be doing a lot of mole conversions this year, ladies and gentlemen. And after a while, some of these you're just going to know. I know during parent teacher conferences back when the math department used to be down here before the second floor was built, if it was a slow day, Mr. Aker would just come in and start quizzing me on the periodic table. Division. 8.02 divided by 12.01. The measurement that started the problem had 3 significant digits. Our final answer should have 3 significant digits. This one, I get 0 point, and remember that 0 doesn't mean anything, 668. I'm going to do one more to wrap up this for the day. How many grams would 0.41 moles of aluminum be? Immediately write down what you're given. 0.41 moles of aluminum. I don't know if that made my 4 better or worse. Okay. Set up a conversion. The question wants me to solve for grams, so grams is on the top. I already have moles. Moles is on the bottom. Eric, what number do I put in front of moles every single time? 1. There you go. But grams is unique to each element. Someone find aluminum. How many grams per mole is that? 26.98. Again, we can round up, we can round down in that hundredths place. So we multiply. Only 2 sig digs in this one. 11 grams of aluminum. Now this, we continue next class. You do not have to do the back side of this worksheet at all for homework, okay?